Okay, today we are learning the rational root theorem. And we have to recall that a polynomial with degree n can have at most n real zeros. The zeros can be rational or irrational. Rational zeros are those that can be written in the form of p divided by q, which is basically, it can be written as a fraction. So for example, a rational number like 3, you can write that as a fraction by putting it over 1, okay? So it can be written as p divided by q. Now let's talk about what the rational zero theorem says. We use this theorem so that we can determine all the possible rational zeros of a polynomial function, okay? So we're not going to be worrying about irrational. We're learning about rational, okay? So if I'm given this polynomial, then every rational zero of the function has this following form, where p represents the factors of the constant term. What's a constant? What's a constant? Exactly. The number that's being added or subtracted. It's just a number. It comes on the very end. So the constant is the very last term. In this case, it's represented as A0, subscript 0. And then Q, you're going to list the factors of the leading coefficient. And can you tell? That's a C. Can you tell which one of these represent the leading coefficient? Yep, an to the xn. Okay. It says that every rational zero will have this format, P over Q. Let's look at an example of this definition here, of this theorem. So for number 1, I have a polynomial, and I want to know what are all the possible rational zeros for this, okay? So we're going to write it as P over Q. P, we're going to list all the possible factors of the constant. What are the possible factors of 2? Yep, 2 and 1, because 1 times 2 will give you 2. But also, -1 times -2 will also give you 2. So those are the possible factors of 2. The denominator Q are all of the possible factors of the leading coefficient. In this case, the coefficient is 1. So the possible factors of 1 is 1 times 1 will give you 1, and a -1 times a -1 will give you 1. Okay, so let's go ahead and write my possible factors. My possible factors will basically be 1, -1, 2, and -2. That is a list of all of the possible rational zeros. Okay? Let's do number 4. Remember, we write this as P over Q. Okay, let's list the possible factors of 16. Can y'all help me? 1, good. 2 and then 4. 8, good. Good. These are all the factors of 16. Now let's list the factors of the leading coefficient, which is 3. 1 and 3, plus or minus, because -1 times -3 will also give you 3. Okay, so guys, let's go ahead and list the possible rational zeros. So your possible zeros, it can either be all of these numbers, right? Because all of these divided by 1 will just be the same thing. Okay, so all of those in the numerator are possible zeros. But also, let's think about this. 1/3, we can also have 1/3. We can also have 2/3. We can also have 4/3. You can have 8/3. And what's 16 divided by 3? Is that possible? Okay, so we also have 16/3. So all of your possible rational zeros are all of the numerator, because all of the numerator over 1 is just what we have in the numerator, plus all of these fractions. Yes, you have to write all of these. These are all possible zeros that you can get if you factor this, okay? So I'm going to let you guys do the rest of these, figuring out the possible zeros. Thumbs up, middle, or down if you get what we're doing. Okay, we'll do another example. I'll do number 5. We're going to list the possible zeros. We do this by doing P over Q. So let's list the factors of -12. Can you guys help me? 1, 2, 3, 4, 6, and 12. And the negative versions of those as well. Because 2 times 6 is 12, 3 times 4 is 12, 1 times 12 is 12. So all of these factors work for 12. Now let's do 6, the leading coefficient. What are the factors of 6? 1, 2, 3, 6. Good. Okay, so guys, this is going to be a little bit longer. I'm not going to skip any steps. All of these divided by 1 will give you the exact same thing. So the possible zeros are plus and minus 1, positive and -2, 3, 4, 6, and 12. All of these over 2. Let's see what that gives me. A 1/2. What's 2 over 2? We already have that one. 3 over 2, we don't have that one. So I'm going to add that to my list. 4 over 2 is just 2. I already have that. 6 over 2 is just 3. I already have that. And 12 over 2 is 6. I already have that. Okay, let's move to the next number. The plus or minus 3. Let's do plus or minus 3 over all of these. So let me circle what we're doing. Let's evaluate the 3 over the denominator. 3 over 1 is just 3. 3 over 2, I already have that. 3 over 3 is 1. 3 over 6 is a half. Am I missing anything? Nope. Okay, let's move on to the number 4. 4 over 1, we have the 4. 4 over 2 is 2. We have a 2. 4 over 3, we don't have that one. So I'm going to add that one in. And 4 over 6 is just 2/3. Right? 4 over 6 is 2/3. Yes, okay. Let's move on to 6. 6 over 1 is 6. 6 over 2 is 3. I already have it, 3. 6 over 3 is 2. I already have it. 6 over 6 is 1. I mean, it's 6. Is 1, sorry. I already have that. 6 is good. Let's try 12. 12 over 1 is just 12. 12 over 2 is just 6. 12 over 3 is 4. 12 over 6 is 2. Okay, so I found all of my possible zeros. Oh, thank you for pointing that out. We didn't do that one. 1 over 6. Thank you. Oh, we didn't do the ones. Let's go back and do the ones. We skipped 1. We just went straight to 2. Thank you. All right, so let's do the ones. Don't ignore that. So let's do green. So 1 over 1, we have it. 1 over 2, we have it. 1 over 3, I just wrote it right there. We have 1 over 6. Let me write that one. And that is it. We already did 2s, 3s, 4s, 5s, not 5s, 6s, and 12s. So these are all of the possible rational values if you were to factor this and solve. Okay? So that is how you list the possible rational zeros. Let's see how this comes in handy. Okay, so we're going to find rational zeros. So step one, we're going to list all the possible rational zeros using the rational zero theorem. And then we're going to test the zeros using synthetic substitution. Okay? All right, so possible zeros. Okay, so we always do P over Q. So let's list the factors of -8. That'll be 1, 2, 4, and 8. The coefficient is 1 here, so the factor is just plus or minus 1. So these are all my possible zeros, just what's up here in the numerator. Everything divided by 1 is what I have in the numerator. Okay, so we listed the possible zeros. Now we're going to test the zeros using synthetic division. So guys, this is a list of possible zeros. These are not all the answers. These are just possible answers. Which one would you like to test?
4.
4? Okay. So the polynomial is right here. We put the coefficients in here. Bring it down. This will be 4, 7, 28. What's this? 22? Yeah, I'm not going to get 0. So 4 is not a good one. Let's try another one.
2.
2?
What about the negative?
So this will become, if this doesn't work, I'll just give you the answer.
Oh, it worked.
It works? What is this? 4, 8. Perfect. We got 0. That means 2 is a 0. Okay, so guys, what we have here is x minus 2 will be a factor, right? Because this is our 0. And then we always go down a degree. We started off with the cubed, so this will be a squared. Okay, so we have x squared plus 5x plus 4. Guys, I need two numbers that will multiply to 4 but add to 5. 4 and 1. So that means my factors will be x plus 4 with an x plus 1. And guys, let's go ahead and solve. So I'm going to equal this to 0, equal this to 0, and equal this to 0. So what are the zeros? -4, -1, and 2. Perfect. And guys, that was -4, -1, and 2. That is from the list of my possible zeros. Okay, so that is how you do these. List all your possible zeros and test them using synthetic division. All right. Okay, so I'm not sure how you want to pronounce his name. Some people say Descartes or Descartes. I say Descartes. I don't know how to say it. That's how I would say it, Descartes. Anyway, this was a French philosopher, and he discovered this right here. That if you look at the variations in signs, you will be able to tell. Well, let's talk about what a variation in sign is first. A variation in sign is when consecutive coefficients have opposite signs. That is what a variation is. So, just so we understand what a variation is, how many variations does this polynomial have? It says when a consecutive coefficients have opposite signs.
0, 2.
Okay, y'all are saying 2. Let's see if you're right. It goes from positive to negative here. It goes from negative to positive here. It goes from positive to negative there. So those are 3 variations. That is 3 variations. Consecutive means in order. Consecutive means back to back. So it goes from here to here. It went positive to negative. That's 1 variation. This one went from a negative to a positive. That's another variation. Then this went from positive to being negative. That is a third variation. Does it make sense what a variation is? Okay, so let's figure out what Descartes is saying. He says that the number of positive real zeros is equal to the number of variations in signs of f of x, or less than that by an even number. Okay? He also says that the number of negative real zeros is equal to the number of variations in signs of f of negative x, or less than that by an even number. I'm going to give you an example of what he's saying here. All right, so how many variations are in f of x? Here's a variation, and here's a variation. Okay, let's go back to the notes. It says the number of positive real zeros is equal to the number of variations in signs of f of x. So how many variations in signs did we just see in f of x? 2. So that means we're going to have, for positive zeros, we're going to have 2. We're going to have 2 positive zeros, or let's continue reading the notes, less than that by an even number. So less than this by an even number. We're going to subtract 2. 2 is an even number, so you can have 2 or 0. Always subtract by 2. So that means what Descartes is saying is that the number of variations that you see, that's how many zeros that are positive that you'll get. So when we solve this, he's saying you're going to get 2 positive zeros, or you're going to get 0 positive zeros. Okay, now let's do the next part. Let's figure out how many negative zeros I'll possibly get. It says the number of negative zeros is equal to the number of variations and signs of f of negative x. So guys, let's look. This is my equation. I'm going to plug in a negative x and see how many variations there will be. I'm going to plug in negative x's here. Okay, so what is a, I'm going to draw it over here for you. This says negative x cubed. That means negative x times negative x times negative x. What's a negative times a negative? Positive. Positive. And what's this positive times this negative? So I'm going to have a negative. So that means this will become a negative 2x cubed. Minus, let's see what I get here. What is a negative x times a negative x? Positive. So I'm just going to write a positive. So guys, even exponents will not change. If it's odd, it will change. This is an odd exponent. You can imagine a 1 here. 2 times a negative x will become a negative 2x. And the plus 1 will not change. So let's look at the variations here. Negative, 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 positive. There's only one variation. So I'm assuming this is what we'll have. We'll have 2 positives and 1 negative. All right, so let's go ahead and factor. Oh, it doesn't want us to solve it. It just wants us to figure out the possible positive and negative real zeros. I'll do one more with you. Let's do number 4. That looks hard. So how many variations are there for for positives? Here's 1 variation, 2, 3, 4. Yep. So you can have 4 possible zeros and subtract by 2. So it can be 2 or 0. Just whatever number you get, subtract by 2. These are the possible zeros that you can get. You can have 4 positive zeros, 2 positive zeros, or none at all. Okay, is what this is saying. Now let's plug in a negative x this time. And guys, there's a quick way to do this. Remember I said if it's even degree, it'll stay the same, and if it's an odd degree, it'll change. Okay, sorry, I ran out of space. Negative x to the fifth will become negative. A fourth degree will remain the same. Sorry, we're plugging in negative x's. Odd degree will change. Even degree will stay the same. Odd degree will change. And plus 8. Is that okay? All right, so let's count the variations. So negatives, okay, it changed from negative to a positive here, and that's it. So it's possible to have one negative value. Now, if you want to, you can write this in word form. You can have 4, 2, or 0 positive solutions or zeros. Or you can have 1 negative 0. Those are your possibilities here, okay? So let's look how this is gonna benefit you. We're gonna combine these rules. Okay, so first, the directions say create a list of all the possible rational zeros. Okay, I'm gonna do number 10 with you. Let's create a list. What are the factors of -4? Mm-hmm. 1, 2, and 4. And what are the possible factors of 2? Good. And just do the positive and negative version of all your numbers. So I'm going to make a list of all of my possibilities. First, 1 over 1 is 1. And 1 over 2 is a half. So let me add that in there. 2 over 1, that's just 2. 2 over 2 is 1. And then 4 over 1, that's just 4. And 4 over 2 is just 2. Okay, so this is my possible list here. My zeros are going to be in this list. I just don't know which one it is. Okay, let's look at step 2. It says, then find all real zeros. We're going to use the Descartes' rule of signs to help you eliminate possibilities. Okay, so let's look at the rule of signs now. How many variations are here? Just 1. Okay, so I'm going to make a little chart. I can have 1 0, and if you subtract 2, you'll be in the negative. So that's just the only possibility. And let's do f of -x. Remember, even powers will stay the same, odd ones will change. So this will stay the same. This is an odd degree, so it will become negative 3x cubed. This will stay the same because it's even. This will change because it's odd. And then the -4. So here's a variation. Here's a variation, and here's a variation. So for negatives, you have 3. Subtract 2, you also have 1 possibility. Okay, so I'm just going to write down here, or I'll write it up here. You can have 1 positive 0, or you can have 3 or 1 negative zeros. That's what the Descartes rule says. Now, we're actually going to solve. So I'm going to do synthetic division. Which one would you guys like to test? 2? Okay, we can do 2 then. Bring this down. 2 times 2 is 4. 1, 2, -5, -10, 2, 2, 4. Ooh, y'all were right on it. We got 0 as our remainder. So guys, this is what I'm gonna do. I know that one of my factors will be x minus 2, because my 0 is a 2. So that means the factor is x minus 2. And we're gonna go down a degree. This is x squared. Oh no, I'm sorry. What did we start off with? A quadratic, a fourth degree of 4. So this will be a cube. Okay, so this is now what I'm left with. So guys, the directions say use Descartes's rule of signs to help you eliminate possibilities. So guys, we already found our positive 2. Didn't our possibility say that there's only going to be one positive? Okay, so I already know that this possibility here is one of my answers. Let's test a different one. This time we should test negatives because it says you'll probably have 3 negatives now, since we found the positive. Okay, so which one do y'all want to test next? -4, okay. Now guys, look what I'm gonna do. I know this is a factor. I'm gonna use this for my synthetic division. Okay, so let's use the polynomial, the new polynomial that I have. I'll do it right here. My new polynomial, the coefficients are 2, 1, -5, and 2. And you guys wanted to test what? -4? Okay. So bring that down. -4 times 2, -8, -7, 28, 23. Yeah, I'm not going to get 0. That didn't work. Which other one would y'all like to test? -1/2 would be ugly. Let's choose a different one. -1? Sure, let's do -1. Okay, bring down the 2. -1 times 2, -2. That didn't work. Okay, guys, let's look real quick. Uh-oh. Uh-oh. Okay, here we are. Let's come back real quick. Okay, let me erase this so we don't get confused. We need to use the polynomial that they gave us for synthetic division. Okay. So the polynomial that they gave us is right here. So this will be 2, 3, -7, -12, -4. Okay, and which one did we test? 2? Okay. Bring down the 2, we get 4, 7, 14, 7, 14, 2, 4, 0. Perfect. We got 0. So that means x minus 2 is a factor. Okay, that was just a coincidence that we got it right. We're supposed to use this polynomial here. Okay, now let's try a different one. Now I'm going to use this right here as my new synthetic division, okay? I'm using this one now. And just so we don't lose track, this is x cubed plus 7x squared plus 7x plus 2. Now I'm using synthetic here. And you guys wanted to test -1. Okay, so bring down the 2. -1 times 2, -2. This is 5, -5, 2, -2. Perfect, we got 0. So guys, that means my factor, I already have x minus 2. That's one of my factors. Now I know that x plus 1 is a factor. And let's write down what this is. This is 2x squared plus 5x plus 2. Okay. Now, if you want to, you can keep going with synthetic division. You can use this 2, 5, 2, and then try another one. Or what I would do, I could just stop here. That's my preference. Do you guys want to stop here and factor this quadratic like you already know how to do? Or do you want to keep going? Okay, let's stop here then. You could do either one you want. So I need two numbers that will multiply to 4, add to 5, because you have to multiply those two together. Good, 4 and 1. So that means it'll be 2x squared plus 4x plus 1x plus 2. We rewrote the 5x to be 4x plus 1x. Okay, so we're going to split this into groups. Find the GCF. Okay, so that means my factor will be x plus 2 because they both share an x plus 2. That's one of my factors. The other one is what is on the outside. So 2x plus 1. So guys, these are my factors after I did grouping here. Okay, so I'm going to write my answer in purple. Okay, so my factors are x minus 2 and x plus 1. And then what I just found, 2x plus 1 and x plus 2. These are my factors. I'm going to label this factors. So guys, based off of my factors, what are my zeros? -2, -1, -1/2, and 2. You just set all of these equal to 0 and solve. And guys, notice my x values are all in my possible chart. Or right here, I should say. All of my answers are found in the possibilities that we put in the beginning. Okay? So you guys can go ahead and finish the rest of these.